Good evening, Math 101 Hazleton. Justin Pashar here once again. I hope everybody's doing well, staying healthy and safe. Beautiful day outside today. Hope everybody was able to get a chance to go outside for just a few minutes. As you know, May 14th is the final exam. Well, it would have been the final exam if we were in class. But as you know, the final exam is going to be take home this semester, of course. So the exam was released on Friday, and the exam is due on the 14th. There's no exceptions. The exam must be in. You essentially have 2 weeks to do the exam. So I can't foresee any problems with you guys. You did a nice job. I really have to commend you once again. I know I said it in the emails, but I'll say it again. Very satisfied with the work. It was very good work you guys put forward through this during this pandemic. The work was still solid, and it's not easy learning math online. And you guys, in a way, are math warriors, if you want to think of it that way, because all the other past classes I had, we never had to do this. So you guys really took the challenge and you stuck with it. I'm very happy. So what I decided to do is I'm going to do a couple videos. I'll do a series of them, and tonight I'm going to do one for you guys that takes us back to chapter 2, which involves the set theory thing. So we're going to look at a couple operation type problems, try to keep it short, and then we'll pick up during the week with the review on logic stuff and number theory stuff, the real number stuff. Okay? So we'll start off, we'll say let A and B be sets so we can perform some operations, right? So the first type of thing we saw was this thing. We have, we say this is A and B, the intersection of A and B. So that's the set of all x such that x is in A and x is in B. So that's the one we looked at first. So intersection of two sets, meaning we want to put only the things together that they have in common, and that makes the intersection. Conversely, we have A or B. So we also have this operation called union, and that's going to be the set of all x such that x is in A or x is in B. In other words, when we want to take the union of two sets, what that means is we just put both of the sets together and it forms a union, or one whole set. Then we've seen this set here. Do you remember this? A complement, right? Remember A complement? So that's the set of all x where x is in U and x is not in A. So you remember how that works? So the complement is everything outside of A. So picture-wise, if this rectangle is the universal set, this represents your set A. A complement would be everything on the outside of A. So if it's in A, we don't want it. So this picture would represent a set of A complement. Okay, that's A complement. Then we also had, let's see what other sets we had. We had this guy here, right here. Do you remember this? A cross B. A cross B is an interesting one. This is the set of all ordered pairs AB, such that little a comes from big A, little b comes from big B. So that's kind of the oddball of the set. The Cartesian product was developed to check gaming odds. Essentially, you can think of the set A as one die and set B as another die, and when you roll them, if you got a 1 and a 2, that would correspond to the ordered pair 1, 2. So this is what we call the Cartesian product. And then one that I probably should have put up here in between is this one, the difference set, A minus B. So this is the one that, if you remember, sometimes gets confused with complement, but they're two different things. So the difference set A minus B is the set of all x where x, I hate when that happens, the set of all x such that x is in A and x is not in B. So if we want an element to be in the difference set, it has to belong in A, but it cannot belong in B. And we'll do some examples here on the board, exercising all of these different possibilities. Okay, so let's see. How about we let the set A be the set of 1, 2, 3, and 4. B is the set of 2 and 5. And C is the set of 1, 3, and 7. And why don't we make the universal set the counting numbers from 1 to 10. Okay? So the universal set is all the counting numbers from 1 to 10. The set A is 1, 2, 3, and 4. B is the set of 2 and 5. And C is the set of 1, 3, and 7. So let's perform a couple operations. Number 1. How about A and B? So if we want to take the intersection of A and B, what would it be? Well, we could write them out if we wish. That's 1, 2, 3, and 4. Intersect 2 and 5. So again, if we want the intersection, we're looking for elements the sets have in common. So it looks like the only element they have in common is the number 2. So it's just the set of 2. That would be your answer. Now how about we take the union? The union between A and B is going to be 1, 2, 3, 4, and 5. Because when we take the union, we just put all the elements together. And remember, whenever you have elements that repeat, you only write it one time. That's it. So if it repeats, just write it once. Okay? Let's see. How about number 3? What if we do B and C? B and C. So if we want to intersect these two sets, what would it be? If you said the empty set, you'd be correct because these sets don't have anything in common. So this would be the empty set. Let's see, how about we do B minus C. So the different set, B minus C. So remember how this has to work. So we start with B. If it's in B, but it's also in C, we don't want it. So for example, 2 is in B, but it's not in C, so we'll take it. 5 is in C, 5 is in B, but not in C, so we'll take it. So the difference of B minus C is the set of 2, 5. So that wasn't too bad. How about if we do C minus B? Does it change? Your answer would be yes. Remember, B minus C would never be the same as C minus B unless under one condition, that B and C are identical sets. Think of it as like ordinary subtraction. You know, let's just take 3 minus 2. 3 minus 2 is 1, 2 minus 3 is negative 1. They're not the same. They only would be the same if you had 3 minus 3 or 2 minus 2. So let's look at C minus B. That means if it's in C and in B, we don't want it. Otherwise, we do. So 1 is in C, but not in B, so we'll take it. 3 is in C, but not in B, we'll take it. And 7 is in C, but not in B, so we'll take it. You see how the two sets aren't the same? That's the typical difference set. How about this one? Let's take a look at A complement and, let's see, A complement and C. That's a good one. A complement and C. Well, we have an A up here, but we don't have an A complement. But if you remember, there's a systematic way to find it. You go to the set A, which is 1, 2, 3, and 4, and you cross those elements off in U, which is the universal set. So we're going to cross off 1, 2, 3, and 4. We're left with 5, 6, 7, 8, 9, 10. So this is going to be the set of 5, 6, 7, 8, 9, and 10. Intersect that with C, which we'll write up here as 1, 3, and 7. Okay, so now you have the intersection. What is the intersection there? Well, this isn't too bad. It looks like there's only one number in common. which is going to be 7. So the answer to this thing is just a set of 7. So that wasn't too bad. Okay, so I'm hoping some of this is coming back, to your memory a little bit. Okay, why don't we do a couple more, huh? So this was 6. Let's see what we can do next. How about, let's see, for number 7, why don't we do B cross C? So B cross C, it's the Cartesian product of B and C. Now remember, long ago, we talked about things like cardinalities, right? So for example, the cardinality of B, do you remember what that is? Cardinality of B counts the number of elements. So B's cardinality would be 2. And if we wanted the cardinality of C, that would be 3. So the trick here is, if you take 2 times 3, that's 6. That'll tell us how many elements B cross C better have. So when we do B cross C, we better get 6 ordered pairs or we did something wrong. So let's check it out. So what is B cross C? What does that second look like? Well, you start with the 2 and you match with everything in C. So you're going to have 2 comma 5. Not 2 comma 5, excuse me. I think I got too much sun today. 2 comma 1. Then we're going to have 2 comma 3. Then we're going to have 2 comma 7. Then we go to the 5. We've got 5 comma 1, 5 comma 3, and 5 comma 7. That looks a little sloppy here. Just rewrite this last row. Here we go. So 2 1, 2 3, 2 7, 5 1, 5 3, and 5 7. That would be the Cartesian product. Now there's a nice thing that happens sometimes is that you might get lucky on a test and we might have to be asked this question, C cross B. Well, you should be very happy to see a question like that one, because if we know what B cross C is, to get C cross B, we just flip-flop the X and the Y, right? For the first coordinate with the second coordinate. So C cross B is going to be a set of 1 comma 2, 3 comma 2, 7 comma 2, 1 comma 5, 3 comma 5, and 7 comma 5. And there you go. So that's nice. If you know what B cross C is, C cross B is very easy. You just flip-flop the first and the second component in the ordered pair. Okay, so that's not too bad. I hope, like I said, this is bringing back some good memories, I hope. If you think about it, this is stuff that we did back in January and February. It's hard to believe that's how long ago. Alright, let's see. Why don't we do one more for tonight, number 9. Let's do something like A and B or C complement. So how about something like that? So now we introduce parentheses. So remember, it's kind of like the order of operations, right? When we did these, we take care of what's in the parentheses first. So we got to take care of the B or C. Now we don't know what C complement is there, right? We know what C is, but we don't know what C complement is. So let's kind of erase this. Okay. So let's figure out what C complement is. So C is 1, 3, and 7. So we'll cross off 1, 3, and 7 in the universal set. And what are we going to be left with? Well, 2, 4, 5, 6, 8, 9, and 10. That's what C complement's going to be. Okay, so that's your C complement. So let's see, what is B or C complement going to be then? Well, B is the set of 2 and 5. And we want to union that with this C complement we just found. 2, 4, 5, 6, 8, 9, and 10. So that's not too bad. We'll take the union, which is easy. That means we just put these two sets together. And they both already have a 2, 5, so we don't have to write the 2 and the 5 again. We'll just write 2, 4, 5, 6, 8, 9, and 10. And what's the last thing we got to do? We got to put A together with this one. We want to take the intersection, right? So A, remember, is 1, 2, 3, and 4. And we're going to intersect that with this set we found. 2, 4, 5, 6, 8, 9, and 10. So we're almost there. You see, it's very systematic, right? We started with finding C complement, then we union that up with B, and now we just have to finally intersect with A. So to take the intersection, that means what do they have in common? Well, it looks like they have a 2 in common, and it looks like they have a 4 in common. So your final set here is going to be 2 and 4. And that's it. Okay? So I think this is a good place to pause. We'll perhaps maybe revisit a little more chapter 2 next time. Talk about some of the other basic things that it's been a while since we dealt with. Okay? So I hope this video will help you. Please watch it during the week. More will be upcoming on other topics. And if you, the students, have any questions you want to specifically ask, please feel free to call, email, text. This way I can make a video with those types of questions on there. And be sure that you make sure you read the study guide also that is posted on Blackboard. So until then, stay safe and enjoy, and I'll see you guys next time.